Another way of using software on the system is using containers. So far, what I've talked about is mostly compiled software. So basically taking the source code of the software and compiling it against the architecture of the system using libraries that are available on the system, and pretty much how you would compile the software on your own local machine. In these slides, however, I will present another way that are containers. The outcome of this presentation is to describe what containers are and how they can be useful in the supercomputing. We will show how to download and run software containers and how you can install containers as a module. So provide containers, using containers or installing containers and having that interface, module interface we also have for other software and that I have just described. Okay, so what is a container? A container is a unit of software, or we can call it a sandbox, that isolates an application and all its dependencies. To be executed, it relies on a container runtime and on the underlying operating system. So basically, what you can imagine is that, let's say you have an application such as, it's made of multiple files, an executable, a few dependencies, libraries. Normally you would imagine of installing your software on your machine and then basically collect all the files and dependencies and including the structures they are installed, and you can bundle them, isolate them in a single unit or a file that then you can see it as an archive, and then you can use that archive to execute that software everywhere, because basically you not only bundle the software but also all the dependencies and the environment it depends on. So that is a container. It's a way of isolating a software installation and make it independent of the software, independent of the system where it was initially built on. To run this particular file or tar file, or let's say an archive of this bundled application, you need a container runtime. So a container itself is basically a file containing all the software you compiled and that you want to isolate from the rest of the system. You want to bring it around. To run that, you need a container runtime or engine that is used to execute the software within the container. So what are the advantages of using this approach? So if you're familiar with virtual machines, the concept is kind of similar. So a virtual machine, essentially, you abstract from the host and you make available hardware resources to a virtual operating system, right? A container is one level above, where you virtualize the underlying operating system kernel, and by consequence also the hardware available on the machine. It's virtualized, and you basically packed an image, a base image of the operating system and all the software you installed within that image. Then that image, to be executed, needs to be run by a container engine which hooks the kernel of the host machine and by consequence all the available hardware resources there. So the advantage is the improve reproducibility and portability. Means like you compile the software once in a very well-defined environment you're familiar with, then you can take this container to a few different systems and be sure you can run that container independently independently of how these systems are configured. It is reproducible because you don't have to install the same software on different machines. And when you install software on different machines, it's always a different installation. So it can vary depending on the dependencies that are already installed on the systems, what versions of those dependencies. When you have a container, you specify exactly what software and dependencies that you're using. So it's reproducible. It's the same software you're using on different systems. So productivity, it's an advantage because you just build it once and you don't have to worry about setting up the environment again. The drawbacks is that sometimes when you compile for a container, and then you run it on another system, your software is not optimized for the host where you're executing in. So, for instance, if you compile something for an MD-based machine, you compile your container. Let's say you compile your container on your laptop which has an Intel machine, Intel CPU. You might not be able to compile your container or run your container that is optimized for the Intel. Won't be optimized for Cetonix where we use the AMD CPUs. So there are few drawbacks. Also, you need a container runtime or engine to run this container. It has to be available on the system, and the MPI and other particular features of a system may not be available within the container. What is a good use case to use containers? We will see them in a second, but when you have a large volume of software to be installed, meaning that there are like a lot of applications of libraries working together to make a workflow viable. And bioinformatics is one such case of a science field where people are using lots and lots of applications, chain them together in workflows, and it's installing these hundreds of packages every time is not feasible. So you build them once, set up your environment in a container, and you bring around a single file to execute your whole workflow. Packages such as TensorFlow or PyTorch, which are machine learning software, these are also very complex to install and build. They have a compiled backend, so written C, C++. Then you have the Python interface. It uses hundreds of Python modules. So not only it's hard to install, but it's also hard on the file system to handle all these many files. Instead, a container is seen as a single file, and it's easier to load into memory and such. There are different use cases to use containers. We install some software on Cetonix. Some software on Cetonix, such as PyTorch and TensorFlow, and some applications are installed as containers, but you don't see, but we have a system called container modules that make this infrastructure transparent to the user. In general, to run a container, you will need a container engine, and we use Singularity at Pawsey. So if you need to run a container, we have the Singularity modules. There are different versions for different use cases, whether your application needs, for instance, if it needs to use MPI, then you would need to load the Singularity MPI. And this, if it needs a GPU support, then you will need to load the MPI GPU module. These various versions depends on the way Singularity is run to make these resources that are installed on the host visible to the container. Okay, let's see. Enough with these talks. Let's see if we have some examples. We don't have. We have a few commands you can use. First of all, you can load the Singularity module. So like any other software, the Singularity needs to be loaded as a module. And the first command that you probably use when you want to use a container, you need to retrieve the container from the registry. Docker Hub is one of those. I can open the link. So it's one of those. It's a website collecting all the containers that people make available. Okay. As an example, you have a container. One of the most popular is TensorFlow or PyTorch. We have a few different. Basically you can see as a bundled version of a certain software. One of what we are going to use now. Let's see if we can search in the example. So you can. One of the simplest examples you can have is Ubuntu container. It's basically a standalone Ubuntu installation or image that you can build on top of to have your own container with your own software. So you can see a container is identified by tags. So it has a name and a tag. A container can be built for different architectures, but if you want to use different architectures or better, if you want to optimize for different architectures, you would need to build for different architecture. So, module load, singularity, then we have the version, and then I say let's do the MPI one. Okay, now the first thing that I can do, I go on my software, and then I will show you why. And then what I can do is I now have the singularity command available. Pull means, okay, I want to retrieve that a container. And so the first thing then the second argument is the singularity command you want to execute. In this case, pull means brings down the container. Then you need to specify, okay, what is the container name, the file name I'm going to create to save this container. So let's say my ubuntu.sif. You can call it anytime you want, any way you want. And then what it needs, okay, what container I'm going to actually pull down. Since we are looking at the Docker hub, the string, the syntax is this one. We start with Docker. And then you actually, you have also, there are different container engine, okay? So we use Singularity, but the most popular one is Docker. There are reasons why we do not use Docker on the supercomputer. We have Singularity, which is, let's say, optimized for the use on the supercomputer. But the way to pull container is similar. So what we need is this string here. So the container name and tag the version. Okay. So what we do here now, just pass this one, and now if it doesn't betray me, then it should start downloading. Okay, so you can see it start doing something. It start downloading. Okay, it downloaded the container. That was quite quick. So what do we have now? Okay, so you have this file here, which is .sif, which is the extension for a container. Now we have this container, which should be rather small. Oh, it's 30 megabytes. Okay, how can we execute a container? So a container essentially is, in this case, is an Ubuntu image. You can see it as an independent set of packages, and in this case, you can see it as a different operating system running on top of our current one on Cetonix through the container engine. So if you use Singularity exec, so for execute, and then you name what container you want to execute. This is my Ubuntu, and then the other argument, okay, what command in the container you want to execute. Okay, so because a container is a set of applications and libraries, so which one you want to execute. I usually run, if to explore a container to see what's inside, I use bash. If bash is installed in the container, I assume so, which is the case. So what you can see is now, if I do clear, so you can see that now I have this prompt, which is different from the one I usually have on Cetonix. So it's Singularity. It tells me, okay, I'm inside the container now. So if I do OS release, okay, it tells you, okay, this is the operative system that I'm running on. So it's not the one of Cetonix. It's an Ubuntu operating systems and etc. So if I do this one, you see what you can see here is that we have all these directories are within everything that is installed is installed in the container. It's not on Cetonix, except for software and Scratch. So what you can usually let me actually then let me do this. If I do ls my software, oops, let's see what happens. You see that I can still reach the file system, my software, even within the container. And the reason is the module that we use to load the container sets up singularity in a way that the container can see this path on the host on Cetonix, even though you're running software that is on within the container. So we are running the Ubuntu operating system within the container, but we have some paths that are mounted in the container that are from the host. This is useful if you want to run a software in the container, but you want to write your output data on the system. You want to see those file systems, okay? Okay. What happens if I do? Okay, this is. Yeah, you try to run modules. There is some errors happening here. It tells you like the lmod, which is basically the actual command to run the module, is not available. That's because we are within the container. So there are a few commands on the system that are not available within the container. If I try this one, so commands that you will see later, for instance, to query the scheduler, for instance, saccount or sq that you all will be seeing later, are not available in the container. But if I get out of the container and I do sq, then I can run that program. Okay. So go back to the slides now. So you can use containers, for instance, if you need, you don't have to install TensorFlow from scratch because it's a nightmare. You can just pull the container, execute the container, it's already there. So that's the main use of containers. But if you can build your own container with your own software, we have a documentation for that, such that you build it once and you can carry it around various system infrastructure. Okay. You can do this other exercise as well to pull the Python container. If you want to use a particular Python bundle, you can do that. But I already went through that. So container modules. Running a container requires loading Singularity and then remembering all the commands. You need to execute a particular application within the container, and it requires a little bit, it's slightly more verbose than actually running the application as if it were installed on the system. So someone came up with this idea of container modules. So using the module system and a few wrapper scripts to make available commands within a container using the module system. For instance, I will give you an example. Always on the system. So module avail. Okay. So this named is an application. What is it? Okay, is the cursor. Okay. Named is an application that we provide to users. We do have few versions installed installed with under this category applications, but you also have a few versions, the GPU versions installed as a containers and provide them as a module. Now, if I do this one, module load, and I can paste. Okay, and then I try to do 9D, and you can see I have a few commands that are available. For instance, 92 version. Will it work? Okay. So there are a few errors here. Because I'm executing this command on the login node, it tells you there is no GPU. Yeah, there is no device. But if you run it on a compute node, it will probably print the information that we wanted to see. But as you can see, I'm executing this program, but this program if I go here, I try to open this pattern executable. What you can see is not really a binary. It's a bash script that calls singularity, a few options, and then the container. And then the command within the container, which is stored under opt named b named2. So essentially, this container module system, and which is installed by this software called Singularity Registry HPC, or SHPC for short, creates module files out of containers so that you don't have to run Singularity yourself manually, especially if you have the same application, you want to run the same application or command within the container in a similar way. This provides you an easy interface for you to run the containers and applications within them. If you're using a container during your internship project and you have a software you're always executing the container, then this might be a way to facilitate that execution. So if you have any, if you think you're going to need this one, then we have documentation on how to create these container modules, and also you can write always an email to the help desk ticketing system, and we can sort you out. There are already there are container recipes of instructions on how to install containers already available within this command. So for instance, TensorFlow is one of the containers that is covered by default by this command. So you can install the TensorFlow container as a module by using simply SHPC install TensorFlow. But if you have your own container, then you need to set up a recipe that is a set of instructions that tells SHPC how you want this module to be created. Okay, in summary, we learned about what containers are and what is a container runtime and how to essentially run containers on Cetonix and make them available on container modules. Any questions on this? I know it's quite a lot to take in, it's all new, and so it's natural to have doubts or questions, but as you use the supercomputer, you get familiar with this and it gets easier. Any doubt on the slides I presented so far? Okay. Yes? Can you use the microphone, please? I cannot. Yeah, they're going to provide you with the microphone.
So can you send us the command line history after this?
That's a good question. Depending on how you configure the container, but usually no. If the command line history within the container is not saved in the outside the container. Okay, so if you care about the history within the container, then you're always better off saving that history yourself. But it depends on how it depends whether the it depends whether you have the history command or the file is used to store the data available within the container. But based on my experience, it's not always the case, and I always save my history within the container. It's usually separate from what you have on your host, because there are two different bash commands, one within the container and one within the one on the host. So there are two different bash. There are two different shells.
Okay, so you cannot able to export it into the TSD file.
Yeah, yes, you can. You can if you run the container. So it also depends on, let's say, okay. So let's say you have ls dot let's say I have a few commands here and then I do history. Let's see what happens, to be honest. Okay, so we have a few histories here. Now, what happens if I log out of this one? So what you can do actually, if you go back in here, okay, it's actually saved. But oops, what did I do? You can always if you care about your history, you can always do history. Txt. Okay, txt. And then you have the file here, my history txt. If you log out of the container, you still have that file because you saved it in your host file system. But if I do history here, let's see what happens. See, there's something here missing.
Yeah, I can see.
So you can see that I have all the commands I had within the container, it's gone.
Yeah. So if that's the case, can you save into history file because of there are a lot of that command that you've thrown is not in the slides. So I want to look into it later if I forget anything.
Okay, the history of what I've done so far. Okay. We also have extensive documentation about containers. So I'll send the history and the commands I've done. So I will send them to the chats and then.
Thank you. That would be really helpful.
Okay, no worries.
I just want to say that this is recorded as well. So if you want to get the recording, which we'll do just after this, then you can go through the commands. That may be easy as well.
Okay.
Where are we meant to run like the shpc command? Like, do we run that like in the container? I was like trying to run it here on mine, and it was just saying like command not found.
Okay, so as like any other software, it's available through the module system. So module avail shpc.
Oh right, okay, I see.
Load shpc. So we mostly shpc. Then you have, I think, yeah, it didn't. Okay, this is the list of commands you can have.
Okay, yeah, I see. I think I might have just missed that.
So, okay, that's not nice. Okay, this is my personal configuration, which is slightly broken, but usually should work.
That it had TensorFlow. I'm assuming it has like PyTorch as well.
SHPC show. Let's see what happens. Okay, I do have a problem with, sorry, my configuration here. But if you run, okay, no much energy provider for. Okay, my configuration is broken because I was experimenting with stuff. So I broke my own configuration. But if you run the SHPC list or view, there are a few commands you can actually query all the containers that are already available to install. If they're not, you can create your own container recipes and then install them. It's all documented in the documentation. If you are interested into that, I can show you that later.
Yeah.
In a
Okay.
second moment. Okay.
Thank you.
We do have a TensorFlow and PyTorch module available as well. Okay. No more questions? Let's see, maybe there is some. Okay, see, there is. This is an example how you can use SHPC. So you load the SHPC command and you try to do SHPC install Python. This is one particular container or like container module that is available to install. And then what happens is the container is downloaded, the module is installed. All you can have to do is basically load that module, and then you will have that Python available. The same as with TensorFlow. Okay. We are at the end of the presentation, and I think we are ready for the pause for lunch, right? Or not? Okay, so then I can continue. Okay, so we can do that now, or yeah, yes, it's a good time. Perfect. Yep.